My name is Wong Li Fong. Today I will be presenting the behavior of light in relation to eye, which is fundamental to understanding how we perceive the visual world around us. As future optometrist professional, understanding the optical principle governing light behavior in the eye is crucial for diagnosing and correcting visual disorder. I will present how light behaves as it enters the eye, how different ocular structures interact with light, and how this principle explains both normal vision and reactive error. Before we dive into the main content, let me outline the learning objective of today's presentation. First, we will understanding how light interacts with the different structure of the eye, including the cornea, lens, aqua and vitreous humors, and finally the retina. Second, we will describe the key optical phenomena that occur with the eye: refraction, absorption, and transmission, and see how each one contributes to the process of vision. Third, we will connect this optical principle to the way images are formed and perceived, and also discuss how error in focusing lead to common reactive conditions such as myopia, hyperopia, and astigmatism. Finally, we will explore the clinical relevance of this principle, how optometrists and ophthalmologists apply them in diagnosing vision problems and correcting them using glasses, contact lens, or surgery. Let's start with basic property of light. Light is a form of electromagnetic radiation. The human eye can detect only a small portion of the spectrum. The visible range from about 380 nanometer violet to 750 nanometer red. One key property is that light travels in straight line, which is why shadows form a sharp edge. But when light changes from one medium to another, for example, from A into the cornea, it is speed slow down. This bending of light, called refraction, is what allows the eye to focus light into the retina. Think of how a spoon looks bent when placed in a glass of water. That same principle applies to light entering the eye. When light enters the eye, it follows a very specific pathway. The first structure is the cornea, which provides most of the focusing power. Then light passes through the aqua humor, a clear fluid behind the cornea. Before reaching the crystalline lens, the lens fine-tunes the focus, and light continues through the vitreous humors, a transparent gel that fills most of the eyeball. Finally, the rays converge on the retina, form an image. If any of these structures are cloudy or irregular, vision will be impaired. For example, cataract cloud the lens, and cornea scar scattered light, both leading to blurry vision. The cornea is like the front windows of the eye. Its curved surface bends incoming light toward the retina. In fact, it accounts for about 70% of the eye's total refractive power. Because the cornea is transparent and avascular, it allows light to pass through with minimal scattering. A real-world example: in refractive surgery such as LASIK, surgeons reshape the cornea to change how it spends light, correcting myopia or hyperopia. Unlike the cornea, the lens is flexible. With help from the ciliary muscle, the lens can change its curvature, a process called accommodation. For instance, when you read a book up close, your lens becomes rounded to increase its focusing power. When you look at a distant mountain, the lens flattens. Unfortunately, as we age, the lens loses flexibility. This condition is called presbyopia, which is why many people need reading glasses after age 40. Both aqua and vitreous humor are crucial, even though they don't bend light much. The aqua humor, which fills the space between the cornea and the lens, nutrients this avascular tissue and maintain intraocular pressure for proper eye shape. The vitreous humor, on the other hand, is a gel that fills the large cavity behind the lens. It keeps the retina in place and ensures light passing smoothly. If the vitreous becomes cloudy, as in vitreous hemorrhage, vision may be severely impaired. Refraction is the most important optical process in the eye. The cornea and lens bend incoming rays so that they converge at the retina. The image form is actually inverted and reversed, but the brain interprets it correctly. A helpful analogy is a camera. The lens focus light on the film or sensor. Similarly, the cornea and lens focus light on the retina. If the light focuses too early or too late, that's when refractive error occurs. In addition to refraction, light undergoes other interaction in the eyes. Some light is refracted, such as a small white reflex you see in the flash photography. Some is absorbed. Retinal pigment like rhodopsin absorb photon to start vision. Most light, however, is transmitted through the clear ocular media. But not all focusing is perfect. Aberration occur. For example, chromatic aberration happen when different wavelengths of light focus at slightly different points, causing color fringes. Spherical aberration occur when peripheral rays do not focus in the same place as central ray. The eyes minimize all this, but they still affect image clarity. When the optical system does not align properly, refractive error occurs. In myopia or short-sightedness, the eyeball is too long and the line focuses in front of the retina. Distant objects appear blurry. In hyperopia or long-sightedness, the eye is too short, so light focus behind the retina. Near touch become difficult. Astigmatism is caused by uneven curvature of the cornea or lens, so light focus at multiple points, creating blurry or distorted image. These conditions are very common and are corrected by lens or surgery. From a clinical perspective, understanding optics is crucial. Eyeglasses and contact lenses correct refractive error by altering the path of light so it's focused on the retina. Modern refractive surgery like LASIK reshape the cornea to achieve the same effect. For us, in the eye care field, mastering this optical principle allow us to diagnose, manage, and treat patients effectively. To summarize, light is an electromagnetic wave that travels through the eye along a defined path. The cornea and lens bend light to form an image on the retina. Refraction is the key to clear vision. But if the system is not perfect, refractive error results. Corrective lenses and surgery are based on these principles. Ultimately, optics is the foundation of vision science and clinical eye care.